In this lesson, we'll take a look at simplifying rational expressions. And rational expressions are basically a polynomial divided by another polynomial. Like a rational number, like 2/3 is the ratio of 2 to 3. It's 2 over 3. It's an integer over another integer. So 18x cubed is a polynomial, is actually just a monomial, and 12x is another monomial, and they're divided, so it's a rational expression. Now, in order to simplify this, look for the largest factor that divides into 18x cubed and 12x, both of them. The largest number that divides into 12 and 18 is 6. So if I divide 6 into both 18 and 12, 6 goes into 12 twice. That's why the denominator has a 2 in it. 18 divides evenly by 6 3 times, hence the numerator still has a 3 in it after we simplify. And remember, when you divide powers with the same base, x cubed divided by x to the first, you subtract the exponent. So 3 minus 1 is 2. The larger power of x was in the numerator, so it's still the numerator. So the simplest form of 18x cubed over 12x is 3x squared over 2. Now the restrictions come from the fact that the denominator, the 12x in this case, is not allowed to equal 0. So we're looking for what values of x would make 12x equal to 0, and those are the numbers we're not allowed to put in place of x, because if this had a value of 0 here, we'd be dividing by 0, and you can't do that. So setting 12x not equal to 0 and then dividing by 12, we would get x is not allowed to equal 0. So the restriction for this 18x cubed over 12x or 3x squared over 2 is just x cannot equal 0. Even though the x is no longer in the denominator, the fact that it was at one point means that we still look at what values would make 12x equal to 0, and that is 0, so the restriction is x is not allowed to equal 0, even though there's no x in the denominator here anymore. For b, I would start with the 75 and the negative 5, and actually negative 5 divides into 75 evenly, and it goes in negative 15 times. So my answer, when I start to simplify here, will start with a negative, and the 15, of course, is in the numerator. Now, a cubed divided by a is a squared. So I would have an a squared in my numerator. And then b squared, and we have a b to the 6 in the denominator. And the larger power is in the denominator, so the answer has the larger power, the power of b in the denominator. And of course, I would go 6 minus 2 is 4, so b to the 4th in the denominator. If you want to write the power of b up here, we'd actually write b to the negative 4 after the negative 15a squared. But we would normally leave this with only positive exponents. Now, in the beginning, there was a power of a and b in the denominator. So I'm thinking about the restrictions now. If a had a value of 0, then negative 5 times 0 is going to be 0. Then we would be dividing by 0, and you can't do that. Also, b to the 6, well, 0 to the power of 6 would also, for b, make this denominator have a value of 0 and hence be undefined as well. So the restrictions are that a and b both are not allowed to equal 0. Now that has nothing to do with the fact that there's a power of a in the numerator. It's only what was in the denominator once upon a time or in the final expression here. For c, we'll start getting into more than just monomial expressions. There's a binomial in the numerator here. And look at as soon as you get past one term, look at what's the common factor of 10x squared minus 13x. And I can common factor an x out of both of those terms. So 10x squared divided by x is 10x. And if I factor an x out of a negative 13x, I have just minus 13 after the 10x. Now that it's in its factored form, and I don't really have to factor the binomial in the denominator. 4x is already in a factored form. It's 4 times x. These two x's will divide out. And so I will be left with 10x minus 13 over 4. So that's the simplest version of this original expression. And once again, now there's no x left in the denominator here, but we look at the original denominator here or here, it doesn't matter which, they're both the same. And so 4x cannot equal 0, so you think of what number would I multiply 4 by to make 0, and of course that's 0. So 4x is not allowed to equal 0, dividing by 4 we get x is not allowed to equal 0. 0 divided by 4 would be 0. So the restriction on this is that this is defined for any value of x except 0. If I were to graph y equals 10x squared minus 13x over 4x, the domain would be all these entire set of real numbers, except, of course, x would not be allowed to equal 0. That's the restriction on the domain. For D, we start getting a little larger expressions. We need to factor x squared plus x minus 12 in the numerator and x squared minus 16 in the denominator. To factor the numerator, we're looking for two numbers that add to 1 and multiply to negative 12, and that would be 4 and negative 3. And x squared minus 16, that's the difference of two perfect squares. X squared and 16 are both perfect squares. So that would factor into x plus 4 times x minus 4. And again, you divide out the common factor. Just like I divided the two x's out here, I would divide the common x plus 4's out on the left side of the numerator and denominator. And so this just simplifies to x minus 3 over x minus 4. That is the simplest version of this original expression. They are equivalent except for, of course, any value of x that are non-permissive or restricted values. To find the restrictions, we look at any factors that were ever once upon a time in the denominator, even including the x plus 4 that was divided out here. So the value of x that would make that factor 0 would be negative 4. Negative 4 plus 4 would be 0, so we can't put a negative 4 in there. And also 4 here. 4 minus 4 would also make the denominator have a value of 0. Now instead of writing them separately, I can say that x is not allowed to equal plus or minus 4.